first thing we have to remember is that we have a periodic table that we can be using to determine information about all the elements. Let's take the element carbon right now. So carbon, 12, 6. First thing is, this has an atomic number of 6. That means there are 6 protons in the nucleus. This has a mass number of 12. The mass number tells you the number of protons plus the number of neutrons. So if you want to find the number of neutrons in this thing, you're going to take mass number minus atomic number to give you the number of neutrons. So this thing has 6 protons, 6 neutrons, because 12 minus 6 is 6 neutrons. Notice that this does not have a charge. In an atom, the number of protons must equal the number of electrons. So this thing has 6 electrons. Now let's take another example right now. Let's do nitrogen. Right now, again, we have 7 protons. There's the atomic number. This has a mass number of 14. That means 7 plus 7 neutrons is going to give us 14. So we have 7 neutrons and we have 7 electrons. But there's such a thing as a nitride ion. That means it has a charge of -3. When something has a charge of -3, it has gained 3 electrons. So this thing then really has 7 protons, 7 neutrons, 10 electrons. Ions are formed by the gain and loss of electrons. Since it's a negative ion, this is an anion. Okay, let's do another one. Let's do sodium. Sodium, mass number 23, atomic number 11. This has 11 protons. 23 minus 11 is 12 neutrons, 11 electrons. Protons have a positive charge, neutrons are neutral, electrons have a negative charge. But sodium likes to lose an electron and become the sodium ion. In this case, a positive charge means it's lost 1 electron. So this thing has 11 protons, 12 neutrons, and 10 electrons. Since this ion is positively charged, it is called a cation. Now, how does an atom get arranged? First of all, in the center of the atom is the nucleus. The nucleus made up of a proton and neutrons. Protons and neutrons. So in the nucleus are the protons and neutrons. Around the nucleus travel the electrons in various energy levels. Okay? We're going to go into that in our next section when we start doing electron configuration. But here's the deal. Most of the mass is in the nucleus. However, most of the volume is taken up by the electron cloud. Most of the mass is in the nucleus. Most of the volume is taken up by the electron cloud. Now, we need to know something called atomic mass. Atomic mass is defined as the average isotopic mass of all naturally occurring isotopes of an element. So, for example, when we have carbon 12, there's the mass number. The number that's listed on your table, 12.0111, actually is the average mass of all naturally occurring isotopes. Do you remember how to do this problem? This would be something like this. 70% times 11.99 AMUs plus 30% times 12.2 AMUs. Remember how to do this? And then you divide it by 100 if you don't change the percent to a decimal. Okay? Percent times mass plus percent times mass plus percent times mass divided by 100 is the average isotopic mass of an element, which is what you see right here. Okay, sorry, it's going to be atomic structure part 3. Even though this is not part of the California standards, you have to know it for me. Quantum numbers. Quantum numbers are 4 numbers used to describe the energy and most probable location of an electron. There are 4 quantum numbers. N equals principal energy level. The principal energy level tells you several things. It tells you, number 1, the amount of energy. Number 2, it tells you distance from the nucleus. Number 3, it tells you the size of the electron cloud. N can be equal to 1, 2, 3, 4, 5, a billion. Okay? Now, let's show it. N equals 1. N equals 2. N equals 3. The lower the energy level, the lower the amount of energy. The closer to the nucleus, the smaller the electron cloud. So if you're going to compare N equals 1 versus N equals 2, N equals 1 has lower energy than N equals 2. N equals 1 is closer to the nucleus than N equals 2. N equals 1 is a smaller electron cloud than N equals 2. As distance from the nucleus increases, amount of energy increases. Also, the formula 2n squared tells you how many electrons can be in that energy level. So if n equals 1, 1 squared is 1 times 2, there can be 2 electrons. If n equals 2, 2 squared is 4 times 2 is 8, there can be 8 electrons in the second energy level. If n equals 3, 3 squared is 9 times 2 is 18 electrons. And if n equals 4, 4 squared is 16 times 2, 32 electrons. 2, 8, 18, 32. Principal energy level, the first quantum number. The second quantum number is L. L is sublevels. The sublevel of an atom tells you the general shape. Remember? Okay? Every energy level is made up of sublevels. In the first energy level, there's one sublevel. What's its name? 1s. Remember, an S has a spherical shape. When n equals 2, there are 2 levels. 2s, 2p. S is sphere, P is dumbbell. When n equals 3, you have 3 sublevels. 3s, 3p, 3d. 3s sphere, 3p dumbbell, 3d beyond the scope of this course. N equals 4, 4 sublevels. 4s, 4p, 4d, 4f. Okay? S, P, D, F. Okay? Here are our sublevels. Now, our third quantum number is going to be something called orbitals. orbitals has to do with orientation. How is the electron cloud directed in space? Okay, now, in the first energy level, n equals 1, there's one sublevel, 1s, there's only one orbital. Now, how many electrons go in each orbital? 2. So you can actually have a 1s2. Remember this? Okay, now let's go to n equals 2. You have 2s. Again, there's only one orbital in a 2s sublevel, one orbital. So you can have 2s2, because how many electrons go in an orbital? 2. Now, we have something called 2p. Remember? S, P, D, F. Okay? P has 3 orbitals. How many electrons go in each orbital? 2. So how many electrons could be in a 2p sublevel? 6. Remember this? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10. Okay? So, S, P, D, F. 1 orbital, P, 3, D, 5, F, 7. Remember how they fill? Okay, let's look at the last one. S for spin. Remember, they can spin in opposite directions. So in each orbital, we say that one electron spins clockwise, the other electron spins counterclockwise. So let's do it. Okay? S. Up, down. Let's do P. They don't pair until they have to. Remember this? D. They don't pair until they have to. Empty seat on the bus principle, right? F. They don't pair until they have to. Okay. Now the Pauli exclusion principle says that no 2 electrons can have the same 4 quantum numbers in an atom. 3 can be the same, 2 can be the same, 1 can be the same, but not all 4. Okay? Now the Aufbau principle says that electrons will go into lower energy levels first. Okay? So, remember, here it goes. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Don't forget the diagonal rule. I would put that in somewhere. This tells you the order in which electrons fill. Thank you.